Hello. So this is my little review of the JYQD motor controller. You can find these on AliExpress, eBay. They're around $7 to $30. The brushless motor controllers, and they actually came up on Prime not too long ago, actually. So what I'm going to do is do a bit of a review of these motor controllers. I have here a brushless hub motor, and I'm going to play it. I'm going to turn it on. I'm going to power it. I'm going to have it spin a bit, and I'm going to go over some pros and cons of this motor controller. If you're using this for an e-bike, it's actually a pretty good, or even for like an electric skateboard, it's actually a pretty decent solution for extremely cheap. But if you're using this thing for like robotics or other sort of things where you need precision and control, this is not really the solution for you, and I'll be going over why that is in a sec. So right now I have my voltage set to effectively 24 volts, then drawing about 10 milliamps, mostly from the LDO that's on there. And then here we have a function generator. I have it set up with low voltage is 0 volts, 5 volts. Actually, I'm going to move this down to 3.3. And the frequency is at 1 kilohertz. The maximum frequency for this thing, I believe, goes from 1 to 10 kilohertz, and I don't want my ears to bleed, so I'm keeping it at 1. And I had it set up for a duty cycle of 30. Just make that 30 completely. All right, oops, 30. All right, so what I'm going to do is I'm going to turn them on. I have this, and also I have this power supply set to parallel mode. So each one of these channels usually gives out around 3 amps, but in parallel mode it will give out 6. Each one of these is dialed up all the way. Won't actually need it for what I'm doing today, though, or what I'm doing right now. Turn this guy on. So let me turn off this, and I'm going to press the output button. Notice that actually ramps up. It doesn't immediately go. Some motor controllers will actually just immediately just shoot into that speed. So this thing ramps up into it. So as an acceleration, there's acceleration smoothing, which is actually one of the pros. Now from here, I can actually attempt to slow it down. It has quite a bit of torque behind it. And this is only around 30%. It's not going anywhere near full speed. If I make it go full speed, the actual table starts to rattle, so I won't actually be doing that. But here's one of the disappointing things about this guy. If you turn off this guy here, and I set this guy down to, let's say, 5%. Let's give this guy a small go. So now he's going. Notice how I had to kind of give it a bit of a start. You might think that's normal for most brushless motor controllers, except for the fact that this is a sensored motor controller. It does have a Hall effect sensor input here. It will not work without the Hall effect sensor input, which is kind of strange that it needs a bit of a jolt in order to get going when it's sensored. But if it's at a higher speed, it'll get going a lot faster. But one of the really disappointing things about this is the fact that if I attempt to slow it down, and I increased, you might be able to hear this. It actually has no starting torque. You want to let it go? There we go. Got to stop it again. Let's go all the way down. So it'll creak out like that, and it'll hold that way. It'll make a lot of sounds. And it has like no starting torque, and it has a bit of a safety feature. So if it stalls out for too long, it will just cut out, so it doesn't draw too much power and doesn't damage itself. It's actually a plus. But it has no starting torque, even though it is a sensored motor controller. So a little bit of the downside, and the reason why it's not as good for applications where you need this for not for like bike assist or for longboarding, but we need this for robotics or in type of like little machine you're trying to build or it might get stuck in something. So I'm actually just going to go through some of the pros and cons of this guy. I would say that one of the pros would be the fact that it is super cheap. Found on Amazon Prime for around, I think, $10, $10.99. All the way up to $30, depending on where you find them from or if they're like in bulk. So like these things are super cheap and they're all over the place. There's no real manufacturer for them, so you won't be able to find information for that. It's super easy to use. Basically the EL is an enable, you have a speed, you have an output tachometer, which is XORs the information from the Hall effect sensors that gives you a tachometer output. Z and F just means forward and backwards, and then VR, voltage reference, is the speed control, which you can also use for a potentiometer. So either you can have a DAC connected to this, a potentiometer connected to this, or you can use PWM to control it as well. And then the output pins are just the 3-phase and the power pins. Excuse all the mess of the wires. The Hall effect sensor is pretty intuitive as well. And it doesn't always, depending on the phase and how your thing's designed, the phases won't always match the exact Hall effect sense pins here. So they kind of figured that out through experimentation. Yeah, and it also has overcurrent protection. So if you draw too much current from this guy above like 15 amps, it will shut off. And if you stall this guy for more than like 5 seconds, I believe, it will auto turn off. You actually kind of saw that when I was attempting to dial it up and then just stopped because it was held for so long. But it won't push beyond that. And that's actually where we get over to the cons. So it's low current overall, which actually it's actually highly efficient, this driver, but overall it can only support up to 15 amps, and a lot of the motors, bigger motors like these, usually go up to some of them 15 amps if they're like the smaller geared ones, up to 40 amps depending on how they're designed. So this might not be suitable for your current for your power usage needs. There's absolutely no starting torque. That's another one of the cons. Even though it's censored, so it's a bit of an issue. It has weak brakes, so right now, let me disable the output. This might not be easy to see. Actually, it's not easy to see. But if I move it this way, it'll go for a little bit, and if I try to move it back this way, it is braking me. The thing is, it's super weak brakes. You could not expect to use this to try to stop to use fast decay braking for your motor. It's just not going to happen. And the worst thing about that is, you might go, all right, well, just active brake, go the opposite direction. Well, because there's no starting torque, it will fall backwards, and then the stall protection will activate, and then the entire thing will actually become loose. It will, just as easy it is to move on this side, it'll be just as easy to move on the other side, which means that you just won't, you won't be able to hold your torque. You won't be able to hold your wheels in any spot, which makes this like really bad for making like a small scale like car, or any type of use where you might get stuck on something. Yeah, and it won't work without the Hall effect sensors. You'll just hear the squeaking sounds of it attempting to move or looking for input for the Hall effect sensors, pretty much picking up noise as a means of figuring out where it is. Which for something that seems to have an algorithm that seems like it was patched in with a Hall effect sensor, and it seems like it's sensorless. It seems like it may. Some of them do have the capability. Some motor controllers do have the capability, but this is not one of them. And there is a version of this particular motor controller that comes without Hall effect sensors. Those ones are actually even worse. All stats of this guy are actually just worse. So if you are going to use one of these, I'd suggest getting the Hall effect sense ones. The starting torque for the censored ones are bad even when the thing's operating and moving. So I mean, just getting a simple hobby ESC would actually be a lot more favorable than actually using one of these guys if you're getting the sensorless ones. If you're getting the censored ones, it's a cheap alternative that could be pretty useful. So yeah, that would be my little review of the JY. I forget the number again, but this is the 0.7. This is this type of motor. It's like 0.7.3E. I put in these. If you're also curious, the last little note is if you're curious about these pull-down resistors, I put those in specifically just to check to see if the signal for the gate would stop fluctuating if I put a pull-down resistor there. If you actually move the tire, and I clip on onto one of these guys here, if you look up on the oscilloscope as I move this, you'll show phase. And it's strange because I thought it would be trying to hold low as they tried to break it, but I think it's noticing. I'm actually not too sure what exactly that is. I expected the gate to either just stay high to try to short the windings in order to make it break, but it doesn't seem to be the case. Let me try. I went a little too far. There you go. So you can kind of see as the gate activates, as I merely move. I can get a good shot of this. So yeah, that's a thing. Yeah, so that's the reason why that's there. It makes no effect. There's no performance difference after putting those in. But yeah, so that's my little review. Hopefully people who find this online will use that information to decide whether or not they want to purchase this for whatever needs they have. And yeah.